Okay, we're going to try to add something to what you can read in your text regarding one sample test. And I've created a quick little outline here that summarizes what I get out of that chapter. And I hope that it will help the teams here as you get ready to do your assignments for the homework. When it comes to one sample test, what we are doing is gathering a sample and trying to make a prediction about what is happening with the larger population. There are populations so large that it would be impossible to go around and get every single value to determine what the population average is. Therefore, thank God that we have mathematicians that have figured out how to create a confidence interval for where the population average might be if we use a sample. And that's how, for example, these guys know how to predict a presidential election so closely as they do, because they're using the mathematics of statistics, and they're taking samples and they're determining or predicting what the entire country will do when they go to the polls and vote for president, and they get really close. Okay, but the impossibility would be to go ask everybody. That's why we have the polls. That's when we ask everybody. Okay, so when we're doing sample tests to determine what the population average is, we use a z-test, or we use a t-test, or we use a z-test for the proportion. Let's go through those real quick. The z-test is when I know what the standard deviation of the population is. I very rarely know that. There are times when we have done so many samples of products coming out of processes over the years that we pretty much know what the standard deviation of the population is, and we confidently can use a z-test where the confidence interval will be a little smaller and we can be more precise. But most of the time we do not know what the standard deviation of the population is. We have to use a different set of mathematics which are involved in what's called the t-test. So I use the z-test when I know the standard deviation of the population. I use a t-test when I do not. Most of the time we're going to be using a t-test. And the other one is the z-test for the proportion. Now, the way the mathematics works on proportions, you don't have the same issues that you do on the t-test and the z-test for data. So we can always confidently use a z-test for the proportion. So that's a proportion would be like when they do a survey to figure out who's going to win the presidential election. They ask people where you're going to vote for, and they get a proportion. 52% say this one and 48% say that one. So then they use a z-test for proportion to figure out, well, what is from that sample, what would I say about the greater population of the country? Okay, so that's some of the applications for it. Now the question becomes, well, would I do a one-tail or a two-tailed z-test or t-test? And it depends on what you choose for your alternative hypothesis and your null hypothesis. The alternative hypothesis is what you're trying to prove, what your hope will happen, and the null hypothesis is the alternative. So you pick the null to be the opposite of what you hope to prove. So for example, you make a change in the service window of your fast food restaurant. That's on page 313 in your text, by the way. So you want to see if the changes you made improved your wait time. So you have your previous month average for your wait times. You now have a sample of your second month's average. So are you better or not? So you hope that the average will be better than before or different. So if you want to just want to see if it's different, then you set HO equals to 4.5. and HA, the alternative, is less than or greater than. This is a two-tailed test. The way I do it is, if I look at that less than sign, it's pointing to the left, the lower tail. The right greater sign, the greater than sign on the right, is pointing to the right, or the upper tail test. So that would be a two-tailed test. If I go down here, I have set it up differently, where the alternative hypothesis would be less than 4.5. Well, that is a lower tailed or left tailed test, because the greater or the less than sign is pointing to the left, and over here it's pointing to the right. So this would be an upper tailed test or a right tailed test. Okay, so that'll be a question you ask sometimes when you're setting up a pH stat test of some kind. Now, what do we do with the results? Well, we have the critical value approach, which says you take your test statistics and you compare them to the critical values. So what you basically do, the critical values are the z-test or the t-test that comes from the level of significance you've chosen. Level of significance is your confidence that you're trying to have. If it were 95%, the level of significance is 0.05. If you want to be 99% confident in your results, it would be 0.01. So what we're doing now is getting what those levels are of significance of 0.05 and converting them into what the t or the z value is, and then we're seeing what our test statistic is, and if it lies between, then we get one result. If it lies outside, another. Okay, then I'm going to show you in a minute how that works. Okay, and then the last one is a p-value approach. This is my favorite. It's a little simpler. You get if the p-value is low, the null must go. If the p-value is high, the null must fly. And the p-value is low when it's below the level of significance, and it's high when it's above the level of significance. And we're going to do a sample right here so we can test that out. Okay, so let's use the section 9.2, I believe it is. Let me go to the PHStat window here. Yes, it is. Section 9.2, pages 318 to 321. They give us a data set. What we have here is a company for 5 years has had an average invoice of a certain amount. They're doing a sample now to see recently if their sales invoices are higher. That's what they're hoping anyway. And so they're going to set up a t-test and see if what it reveals. Okay, so we go to our add-ins, go to PHStat, and we go down to one sample test. The t-test for the sigma unknown. By the way, our data comes from the Excel data sheets. It's called invoices if you look at that information on those pages. The null hypothesis is 120. The level of significance they chose is 95% is the confidence level, so the level of significance is 0.05. Let's get it from the samples. We go here and highlight this, and we push the button. We are going to do a two-tail test here. We know that by the way the hypotheses are set up. Okay, push the button on that two-tail test, and there's the answer. And on PHStat, they tell you right there what to do with the null hypothesis, and it is to reject the null hypothesis. Okay, so they were hoping that it would be different. It was not different. All right, that's how you do it on PHStat. The critical value is the test would be this. The lower critical value is minus 2.2, and the upper is 2.2. This number of minus 9.1908 lies between those two values. It's not as negative as this one, and it's not more positive than that one. It lies between them, and that's why you would reject the null. In the case of the p-value, they calculate the p-value to be 0.2588. Well, that's a high p-value. That is above the level of significance of 0.05. And when the p-value is high, the null must fly. And so in this case, the invoice amounts recently are the same as they've been for the last 5 years. They have not made any significant strides in that area. Okay, and that's what they can ascertain from the null being rejected. Okay, now the tricky part: how do we do this in Excel? Well, if you go to your text and look on page 320, they give you the formulas. If I look here, there's a formula. There's the formula for that one. Up here is the formula for this one. They give you the formulas that PHStat uses. Okay, so what we have to do is when we go to Excel, put in those formulas. I did that here. There's the hypothesis. That's data I have to load in. I loaded it into column A. Here's the level of significance 0.05. The sample size is 12. That was calculated actually. No, it's not calculated. I put it in. The rest of this is all calculated because I used the formulas and just plugged them in from what the PHStat gave me. Now I have the ability to do that very same problem in Excel. Now your challenge as groups is to do that same thing for all your homework problems, and there are going to be different tests that you have to do. Some will be a z-test for a proportion, and some will be a z-test with the standard deviation of population known. This one is set up right here, and it could be a template, in fact, for a t-test value, a sigma value unknown. So I'm going to save this one so that you can use it at least in that type of situation. But you'll have to determine, just like I did here, by looking in the book at their output and looking at the formulas are and put those formulas into your Excel data sheet, and then you should be able to get the same answers that you would get with PHStat, like I've done here. Okay, so if you have any questions on this, you can come to the forum, and I wish you the best on all your group projects this week. Thank you.